Hi, it's time to do some thinking and communication problems on polynomials. Here's one. What could the graph of a polynomial function that has range y belongs to real number so that y is less than equal to 15 and 5 turning points look like? Well, when you read these problems, try to read them again so that you really understand what the question is asking. Now here they say what could, that means all the possibilities, right? The graph of a polynomial function. So we have to draw a continuous graph that has a range y less than equal to 15, an upper bound. So only even degree polynomials can have upper bound, not odd degree. And the maximum is 15. And 5 turning points look like. So 5 turning points we have to make. Okay, let's go through it. So let's explore. So this is our coordinate axis, and in this let's draw a line here representing 15. Our graph has to be below this line, correct? So there are a couple of possibilities. Let me draw one for you. Let's say we draw a graph like this. 1 turning point, 2 turning point, 3 turning point, 4 turning point, and fifth one, let's take it to the maximum and then bring it down. Here we are. Now, looking at this, we can say for sure that the graph is even degree. We'll see what the degree should be, correct? 1. And second, end behavior is? What is the end behavior? We are extending from coordinate 3 to coordinate 4. So, when x approaches minus infinity, y approaches minus infinity. And when x approaches plus infinity, y approaches minus infinity. Both ways, it approaches minus infinity, correct? So, it is going downwards, right? Now, let's also look into x-intercepts. X-intercepts. Now, let me write x-intercepts here. Minimum is 2, right? How about maximum? Well, think about bringing all these things down, then we could have a graph which could be something like this. 1 turning point, 2 turning point, 3 turning point, 4 turning point, and we go up to the maximum and come back. So let's see how many x-intercepts we have now. 1, 2, 3, 4, 5, 6. So maximum turning x-intercepts will be 6. So for turning points equal to 5, we can have maximum 6. Fine, so that's good. Now what degree? Now degree is kind of critical. Let's get into more details of this graph. Now to find degree, what we can say that at least we know minimum degree is what? Minimum degree is? Well, this is kind of each 0 is of order 1. So if each 0 is of order 1, then we get our minimum degree. So it's an even degree function, and how many zeros are there? 1, 2, 3, 4, 5, 6. So even degree function with minimum degree of 6. That makes sense. If degree is n, then n minus 1 is the maximum number of turning points. Now, we can change our graph a bit. That means we can make zeros in a different fashion, maintaining our turning points. So this time I'll draw a graph with more degrees. Do you see that? So that you can appreciate how and why are we saying minimum degree of 6. Look here. Let's say this will make one, we'll have so many turning points, so 5 turning points, but we'll change our nature of zeros. Here it is. This let's say first 0 is like kind of odd. Do you see that? So let's say that this is our end behavior, and we go up and come here, and this time we turn. This is also a turning point, right? So we have got turning points as 1, and this is the second turning point. Now second turning point we come back and again hit with a 3 degree. And here again we go like this. And then, see how many turning points are there? 1, 2, 3, 4 and 5. And now let's again go like a cubic type of function. Do you see now what I have done? I have maintained the turning points, 5 turning points. But I have given multiplicity to our zeros. Here the multiplicity is 3, then 2, then 3, then 3 and again 3. Well, this could even be 5, 7, who knows? Flatter it is, more it is. So, well, at least it seems to be of degree 3, 4 and 5, 5 and 3, 8, 8 and 3, 11, 11 and 3, 15. So it could be any number. You understand? So, to be on safe side, sorry, this is about degree. So it could be any number. It could be 6, 7, this and this. That's why it is safe to say that the minimum degree is going to be 6. So, given this kind of a function, we can say that we have a polynomial with even degree whose minimum degree is 6 and which make at least 2x intercepts and maximum 6 intercepts. And the end behavior is going from quadrant 3 to 4. If x approaches minus infinity, y approaches minus infinity. If x approaches plus infinity, y approaches minus infinity. Correct? That's how it is. I hope you understand and appreciate. Thank you.